In this video, we're going to learn how to create scatter charts and then run a regression. In this problem, we want to predict graduation percentage, column G, first using SAT to predict graduation percentage, then using acceptance rate to predict graduation percentage, expenditures per student to predict graduation percentage, and top 10% high school to predict graduation percentage. So because we're predicting graduation percentage, column G is going to be called our Y variable or our dependent variable. And all the other columns, C through F, are going to be our X variables. We can't use column A or B as X variables because they're not numbers. There is a way to code them. You'll learn that in a more advanced class, but right now we're going to use the numerical variables as predictors of our Y variable. So first, to create the scatter chart, it is very important that your Y variable is on the right side of the X variables. So if graduation percentage were column C or D, for example, we would have to copy it and make sure that it is on the right-hand side. So first, let's prepare our scatter charts, and what we're looking for is a relationship that looks kind of linear, that's either upward sloping or downward sloping. So let's start. First, we'll do the scatter chart for median SAT versus graduation percentage. So I'm going to click in cell C3. I'm going to select all of column C, all the way down to the end, down to row 52. Now I'm going to hold down the control key and use my scroll bar to scroll up, because if I use my wheel, I'm just going to change my zoom. Now I'm going to click cell G3 and select the range G3 down to G52. Now what's very important is you have the same number of rows in the two selections. If you do not have the same number of rows in the two selections, Excel will not be able to create the chart. So now I'm going to click Insert, and notice there's an entire charts area, and there's one that looks like a scatter chart. Insert Scatter XY or Bubble Chart. I'm going to click the down arrow and just choose the first scatter. And we can see here that that one doesn't look bad, but the name is graduation percentage. I'm going to change the name for that one to median SAT. Now I'm going to drag this chart a little bit out of the way, make it a little bit smaller so we can compare our charts. And now I'm going to do exactly the same thing for acceptance rate. So I'm going to select the range D3 all the way down to D52, hold down my control key, use the scroll bar on the right hand side of the screen to scroll back up, then select the range G3 down to G52, being very careful to select the same number of rows in both selections, and do exactly the same thing. Insert, click the Insert tab. In the Charts group, click Scatter XY, and then Scatter. And that one looks a little bit less linear. I don't know about this one, but we will call this one acceptance rate. Make this one a little bit smaller, and then drag this one off to the side. The next one we'll do is expenditures per student. So select the range E3 down to E52, hold down that control key, scroll bar up, G3 down to G52 selected. Make sure we have the same number of rows selected. Click the Insert tab. In the Charts group, Scatter or Bubble. Select the top left-hand one. That looks even more messy with one huge outlier over there. So let's call this one expenditures per student. Make that one smaller. Drag that one under. And finally, our last chart is going to be very easy because the range is continuous. So let's look at top 10 high schools. So I'm just going to select the range, F3, down to G52, insert, charts group, scatter XY, top left-hand corner scatter chart, and that one also does not look very linear. Just so I know what I am looking at, this one is the top 10% high school. So change the title. Make this one smaller and drag this one to the side. And looking at the four charts, it looks to me that the median SAT is the most linear of the four, with acceptance rate second. Now what we're going to do is we're going to do some regressions, which will give us more information about these relationships. So now to run a regression, we need to add the data analysis tool. So what I'm going to do is I'm going to click the Data tab, and all the way on the right hand side you should see an Analyze group. If you don't worry, I'm going to show you how to add it in just a moment. Well, the data analysis tool is available in this Analyze group. Now if you do not see this Analyze group, or you only see the solver, in order to add the data analysis tool, what we're going to do is we're going to click the File tab. Then at the bottom, we're going to click Options. On the left-hand side, we're going to go near the bottom and click Add-ins. Down at the bottom, where it says Manage Excel Add-ins, you're going to click Go. And then just make sure that Analysis Tool Pack is checked. If it is not checked, just click the box to make sure that it is selected. I don't need my Euro currency tools. And then once the checkbox is in the box, just click OK, and you should see your Analyze group pop up and your data analysis tool. So now I'm going to click Data Analysis, and I'm going to scroll down until I see Regression. So I'm going to single click Regression and then click OK. So now for the regression, we're going to input the Y range and we're going to input the X range. So for the Y range, remember, as I said, we're trying to predict graduation percentage. So our Y range is going to be column G. So for my Y range, I'm going to select G3 all the way down to G52. Now, in my X range, we're going to do our first regression first. So in my X range, I'm going to do median SAT first versus graduation percentage. So now in my X range, I'm going to select the range C3 all the way down to C52. Now, this next step is extremely important. Because I included row 3, notice row 3 are not numbers, they are letters or labels. Excel cannot regress letters or labels. So it's very important that we click this Labels button. If this Labels button is not checked, what is going to happen is this regression will fail because Excel will tell you that there's non-numeric data. Now, if I start from row 4 and I click the Labels box, what would happen is it would think that the name of column C is 1315. So by clicking the Labels box, you'll see in the output, instead of getting X variable 1, we're going to get median SAT. so we'll actually know which regression is which. So now I'd like to put this regression on this current worksheet. I could put it on a new worksheet, but I don't have another worksheet in this workbook. So what I'm going to do is I'm going to click the button for output range. Once I click the button for output range, I have to click in the output range box and give it a location. So I'll use the horizontal scroll bar at the bottom of my screen to scroll out a little bit to the right. And I can always move this box, and I'll click cell P1 just to get it away from the charts, and Excel always pastes down and out, so it'll paste everything to the right. And now that I have everything together, all I have to do is click OK, and notice there are check boxes down here. Later on, when you get more advanced, you can have Excel produce residuals or residual plots or normal probability plots, but we're just going to do the basic regression, so I'm just going to click OK. So when I scroll to the right, I can see my summary output. I'll click away to deselect this range, make column P a little bit wider and column Q a little bit wider. So this regression is for median SAT as predicting graduation percentage. We can see the median SAT in cell P18. That's because we chose the labels. So I'm just going to name this regression. So in cell R1, I'm just going to type median SAT just so I know which regression is which. One of the first statistics we're going to look at over here is the R-squared value. The R-squared value explains what percentage of the variation in graduation percentage is explained by median SAT. And we can see here that our R-square is 0.318, so it means that about 31.8% of the variation is explained by this regression. Not great, not super horrible, not great. And let's move on with our other regression statistics. So we can see here the significance F is a very low number. This is scientific notation. With the negative 0.5, E negative 0.5, it means there are 5 zeros before the 2.43. So it's 0.0000243. So a number much lower than 0.05. The significance F is the probability that this regression is not good at all. Now we take a look at the p-values. The p-values tell us the probability that each one of these coefficients do not belong in the equation. So the p-value does say that the median SAT is a good predictor of the graduation percentage, but it looks like our intercept might need to be taken out. That has a p-value of 0.937, so that means that there's a 93.7% chance that this coefficient is not negative 1.438, it is actually equal to 0. Now, if you've already gone through the quantitative methods pack, hopefully these statistics should be familiar to you, but if you haven't yet, this is a nice intro and you will be studying them soon. Now let's move on to our other 3 regressions. We're just going to do them very similarly. So I'm just going to scroll back because I'm going to need these columns. So my data tab is still selected. If it isn't, just click data tab. And then all the way on the right in the Analyze group, I'm going to click Data Analysis. Make sure Regression is selected, and then click OK. My Y range is correct because I'm still predicting graduation percentage, but this time, instead of column C, I want column D as a predictor. So I'm just going to delete my X range. I'm going to select it and then hit the delete key. And then I am going to scroll up and I'm going to select the range D3 all the way down to D52. Making sure that Labels button is selected. I have row 3 and row 3 and row 52 and row 52. It's very important in the regression that we have the same number of rows selected. And now I don't want to replace my previous regression, so I'm going to change my output range. So I'm just going to delete where it says P1 in the output range, and this time I'm just going to click on cell P21. And I'm going to click OK. And there's my summary output, and this one is for acceptance rate. So I'm going to note that this is for my acceptance rate. This one has an R value of 0.30, so a little bit less than our 0.31. We have our coefficients. We have a good significance F. We have two very low p-values. So this regression looks okay, except for the extremely low R-squared value. Now let's go through our remaining two regressions. So I'm going to scroll to the left so I can see all of my columns. Click Data, Data Analysis, and Regression, and click OK. This time I'm going to change my X range from column D to column E, expenditures per student. So I'm going to select the range E3 down to E52. The Y range remains column G. But now I don't want to overwrite my previous regression. So in the output range, I'm going to backspace. I'm going to scroll down, and I'm going to skip a couple of rows and just click on cell P41 as my output range, and then click OK. Now I have my third regression for expenditures per student. So now looking at our third regression, we can see from the R-squared value that it explains way less than 1% of the variation in graduation percentage. I thought so when I looked at that scatter chart, that the whole thing looked like a mess, that it didn't look like there was any relationship. So it looks like our third regression, expenditures per student, is one that we shouldn't even bother with because we can prepare the model, but it doesn't explain very much of the variation in graduation percentage. We can see here by the significance F, we have a 77% chance that there's absolutely no relationship between the variables whatsoever, and they're not good predictors. And notice how our p-value for expenditures per student, also 77%, means that there's a 77% probability that the true coefficient is 0, and expenditures per student have nothing to do with graduation percentage whatsoever. Now let's run our final regression. So I'm going to scroll all the way up, and I'm going to scroll to the left, making sure I'm still on my Data tab, Data Analysis, Regression, and click OK. And now this time I'm going to change my X range from column E. I'm just going to delete that, and I'm going to change it to F3 to F52, top 10% high school. Now the only other thing I have to change is that output range, otherwise I'm going to overwrite my third regression. So I'm going to backspace an output range, use my scroll bar to scroll down, skip a couple of rows, and click in cell P61 and click OK. And our final regression is for top 10% high school. So I will note that, make it easier to read. And once again from the scatter graph, it didn't look like this was a very good relationship, and we can see here from the R-squared that this model only explains about 2% of the variation. We have a 0.34 significance F, way above 0.05, our threshold to look at this model with a little bit of skepticism. And now we can see here that our p-value for top 10% high school, also 0.34, means that there's a 34% chance that this coefficient is actually 0 and it doesn't affect the output. So, based upon our 4 regressions, I would automatically reject expenditures per student and top 10% high school. So it's between median SAT and acceptance rate as the best predictor. What I would do, it's not necessary for this project, but what I would do is rerun this regression, taking out the intercept, because the intercept has a very high p-value. I'll show you how to do that. In order to do that, you would click Data and Data Analysis, go back to your regression, and what you would do is click this button, Constant is 0. So we would rerun the regression with our median SAT, which as I remember is column C, and click the constant is 0, and then see if our model is better, if our R-squared values improve, and if it explains more of the variation. So there we go. I'm going to cancel out of this. This is how to produce scatter charts and run single regressions.